Hello and good morning. Welcome, class. Thank you for being here today. My name is Mr. Myers, and we're going to be studying probability today. This is one of the most important subjects that we barely touch on in high school. Probability is in the Common Core, and it seems to have a hard time finding its place in algebra or geometry. Students usually love to ask me, when will we ever use this? So I've got some examples and I'm going to answer that question hopefully today. But also to answer that question, we need to discover what is statistics and what is probability and how do they relate to each other. So let's first look at what probability is. Probability is the study of how likely an event will happen. And so that's what we're going to be focusing on. And statistics is it usually goes hand in hand with probability, and it is the science of collecting and analyzing large pools of data for the purpose of interpreting and presenting proportions that describe the world around us. All right, so we're going to look at an example here, and this example we're going to first look at it from a statistics point of view. And I just thought, you know, what if we wanted to know how many people in the US owned a car? First, you see from your research that 263.6 million cars are registered in the United States. And this is a statistics that I actually pulled off of Google search from 2015, so it's not super recent, but it was there, so that's the number I used. It's probably higher now. Next, you might want to look at how many people live in the United States right now, and currently we have 327.2 million people in the US. Lastly, another number that I found was 227.5 million people in the U.S. have a driver's license. I didn't actually use that number, but I initially thought that might be something we would want to look at, and we could. But it was just a number that I did find, and I thought it was interesting to see. So now that we've looked at how many Americans own a car, and that's what we're trying to figure out. I find a statistic that said that 85% of American households own a car. So it actually explains that we don't really calculate how many Americans own cars, but how many households do. Mostly because, you know, when you're married, you have a car and your spouse also has that same car, so you share your vehicles. So that's why they said, look, we don't really look at how many people own cars, but how many households own a car. Interestingly, a statistic that is a proportion, usually given in the form of a percentage. So usually we give it in the form of a percentage rather than saying 1 over 5. So 1 out of 5 Americans, we might say 20% of Americans. So it's just interesting to kind of keep in mind the fact that there's different ways of saying the same thing. So we could take the number of cars in the U.S. that are registered right now and divide it by the number of people in the U.S. to see how many people on average own a car. That would be a reasonable thing to do. So I went ahead and did that. I took 263.6 divided by 327.2, and those are in millions, but that's fine. Since they're both in millions, we're going to get a good number. And this equaled 80.56%. roughly. So about 80% of Americans could own a car based on our numbers. Obviously, a lot of people own more than one car, so that can mess with the numbers a little bit. So the question that I had was, how did they get this 85% of Americans who own a car? So you may notice some of our data was very accurate, such as how many cars are registered in the US. This is well documented and it's very accurate. But however, how many cars are driven that are unregistered? That's a question that I was wondering. And did they take that into account? Because that would change the number of vehicles on the road. At this point, you may realize that the numbers I've listed may be slightly inaccurate. So this brings us to probability, which is what our focus is anyway. So an example here would be, we want to know how accurate is 85% of American households own a car. Simply put, if we can figure out the number of times an event will occur divided by the total number of events, we would have an accurate probability. The likelihood something will occur. So in our example, the probability, exactly 85% of American households own a car, is nearly zero. It's unlikely that exactly 85%. It might be 84.63. And is that an accurate number then, 85? So it's probably unlikely that it's exactly 85, but we may want to ask, how confident are we that it's around 85%? Or is it between 80 and 90%? And how confident can we be in that? So a lot of times with probability, with a really complicated example like this one, we're no longer looking at a probability. We're more looking at our confidence level in the probability that something would occur. So we will be going into confidence levels and all that fun stuff later. But right now I just want us to do some simpler examples of probability. So let's look at some simple probability. So I would like you to pause the video and go and find 2 or 3 quarters if you can. If you don't have quarters, you can even use pennies, it doesn't matter. They just need to have a heads and a tails. And then also go ahead and find yourself a couple of dice if you have. If you don't have dice, that is okay. You can still figure it out theoretically, or you can just watch the video and you'll understand. But go ahead and find yourself some quarters and a couple of dice if you have, and a deck of cards if you have. So go ahead and find those 3 things. Go ahead and pause the video and find those. All right. Now that you have 2 coins, 2 dice, and a deck of cards, let's begin. I want to know what is the probability I will get at least 1 heads when flipping 2 coins. So go ahead and take 2 coins, and we want to flip these 2 coins and see what the probability will be of getting at least 1 head from the 2 coins. So I go ahead and flip the first coin, and I got a tails. And I flipped the second coin. It wasn't a great flip, but I got 2 tails. So let's go ahead and record that. So 2 tails. So we'd like to do this a few times just to see if we could ever get a heads. So let's see here. Oh, I bet that came off the screen. There we go. So we've got a heads and a tail. Alright. Oh, there we got a heads and a heads. Oh, I got heads and a heads again. Wow. There I got a tail and a heads. And another tail and a heads. So the way probability works is the more times you do it, the more accurate you will get as far as what the probability is, the odds are. So if we did this 1,000 times and we calculated how many times we got heads out of how many times we didn't, and figured out our probability, we would be much more accurate than if we only did it, let's see, we did it 1, 2, 3, 4, 5, 6, 7 times. So doing it only 7 times doesn't make it as accurate as if we had done it 100 times or 1,000 times. So let's go ahead and flip the page here. So you may notice from our practice flips that we sometimes got heads, 2 heads. Sometimes we got a heads and then a tails. Other times we got a tails and then a head. And then other times we got 2 tails. So we need to find out how many of these outcomes are successful and how many of the outcomes are failures. Remember our test. What we're testing is when we flip 2 coins, how likely is it to get at least 1 heads when we flip 2 coins? At least 1. So we could get 1 or 2, and that would be a success. So 1 heads and 1 tails is successful. 2 heads is successful. A tails and a heads is successful. But 2 tails is a failure. So you might notice that there are 3 ways to get a success and 1 way to fail. So to calculate the probability, what we need to do is use this formula here. Probability is equal to the number of successes divided by the total number of possibilities that can happen. So in this case, 3 successes out of 4 total possibilities. So 3 divided by 4, that is our probability of getting at least 1 heads when flipping 2 coins. The total possibilities, 3 successes plus 1 failure, will equal the total possibilities, which is 4. So 3 divided by 4 can be converted into a percentage. 3/4 is the same as 0.75, and to get a percentage you just multiply that by 100. And so 0.75 times 100 is 75%. So our probability of getting 1 heads or more when flipping 2 coins is 75%. So 75% of the time we will get heads when flipping 2 coins. Note probabilities do not guarantee outcomes. They only tell us what the most likely outcome is given a long enough time of doing it or enough times. So if you do it 1,000 times, you're going to get 75% of the time heads will pop up and 25% of the time no heads will pop up. But you know, if you did it 1,000,000 times, it would be even more accurate. So you'd get even closer to that 75%. So we will have a small assignment that I will also post that you can now do. So thank you.